In an experiment, block 1 is given an initial speed v0 toward block 2, which is initially at rest. The blocks are on a track that has a motion detector setup as shown above. When the two blocks collide, there is a completely inelastic collision and the blocks move together with speed vf. The blocks were both placed on a balance, and it is determined that they have the same mass. The experiment is repeated for 4 different initial speeds, and the data are shown in the chart below. It appears that the resulting data are not accurate. Which measurement most likely produced error in the data seen in the chart below? If the two masses were exactly equal and no errors are present, the final velocity should be half of the initial velocity. If we go down the list of options, we can see which of them are not logically consistent with the given results. In the case of option A, a mass m2 smaller than the recorded mass will result in a greater final velocity, not less. In the case of option B, if the actual velocity were larger than recorded, the final velocity will also be larger, not smaller. For option C, the proximity to the sensor does not affect the measurement of the speed. For option E, the experimental error, if the masses and speed measurements are accurate, is at least 15%. That is hardly an acceptable margin of error. In the case of option D, the possibility is that the track is not completely frictionless, in which case, if the final velocity was measured too long after the collision, some of the momentum may have been lost due to friction. That is the only answer that makes sense. Option D.